Hey guys, so I put up a poll on YouTube asking like which topics like you guys find difficult in GCSEs, and transforming graphs like won that poll. So let's revise transforming graphs and let's clear out all of our confusions. So if you look at the first question, it says the graph of y to f of x is shown below. Coordinates of the maximum point of this curve are 1, 4. So this over here is your maximum point. Write down the coordinates of the turning point of the curve with equation y equals to f of x plus 3. So now remember, whenever you have like a value being directly added to x or directly being subtracted to x, it's going to be a horizontal translation. So horizontal translation. If y is f of x plus a, or y is f of x minus a. Now a is a constant over here. So if it's plus a, that means you are subtracting a from x. And if it's minus a, that means you're adding a to x. Now, I know it sounds confusing because if you look at the equation, we are doing the opposite. For x plus a, I'm saying that you're going to subtract a. And for x minus a, I'm saying you're going to add a. So the thing is, the rules are opposite when it comes to horizontal translations. For in this case, y equals to f of x plus 3, what we will do is we will subtract 3 from 1. So that's going to give us negative 2, 4. Now this shows that the graph is moving 3 units to the left-hand side. So now it's going to come somewhere over here. And our turning point will be negative 2 and 4. As you can see, the y value is exactly the same. We're not changing anything about that. Why? Because it's a horizontal translation, not a vertical one. So the only thing that's going to change is your x coordinate. Once again, y coordinate remains the same. So when you subtract 3 from 1, that gives us negative 2. If, for example, it was f of x minus 3, then what we would do is we would add 3 to 1. So that was going to be 4, 4. So then in that case, your graph would move over here. This is for f of x minus 3. And this is for f of x plus 3. So once again, if something is being directly subtracted from x, you move that many units towards the right-hand side. And if something is being added to x, you move that many units to the left-hand side. Now, if you look at part B, it says y equals to negative f of x. So when your y value is being negative, what I mean by that is, originally y equals to f of x, right? So f of x basically represents the values of y. That means y equals to 4. So if y equals to negative f of x, y equals to negative 4. Which means what will happen now is your graph will be upside down. It's going to be y negative 4. That's going to be the coordinate for the turning point because we reflected the graph in the x-axis. So for this, it's going to be a reflection in the x-axis. So the coordinates are going to be 1, negative 4. As you can see, nothing happened to the x-coordinate. It's exactly the same. The only thing changed is the y-coordinate because we're reflecting the graph in the x-axis. So when you reflect the graph in the x-axis, x values are exactly the same. What changes are the y values. Everything that's positive becomes negative. or vice versa, depending on what the shape of the graph is. Next part says y equals to f of x minus 3. Now, if you compare A and C, we can see that in A, the value was being directly added to x. Over here, the value is being subtracted from f of x. And as I said, f of x equals to the y value. So now what's going to change is the y coordinate. So since it's y equals to f of x minus 3, that's going to be y equals to 4 minus 3, because y value for the turning point is 4. So 4 minus 3 is 1. So your coordinate is going to be 1 and 1. If we draw the transformation for this, originally it's 1, 4. So the new one is going to be 3 units down. So that's going to come over here. That's going to be 1, 1. There's a vertical translation. And the graph moves 3 units down. If it was y equals to f of x plus 3, then you would move 3 units up. So now if we compare the horizontal translation with the vertical translation is much simpler and easy to understand, because as you can see, if like a number is being added to the function, you move up. And if a number is being subtracted from the function, you move down. Whereas in the horizontal translation, it's the opposite. If you subtract a number from x, you go to the right-hand side. If you add a number to x, you go to the left-hand side. So this is one way through which you can distinguish between the horizontal and the vertical translations. Then for part D, it says y equals to f of negative x. Now, if we compare B and D, over there was a negative sign being attached to the entire function. In D, there's a negative sign being attached directly to the x value. So which means it's going to be a reflection in the y-axis now. In the previous case, it was a reflection in the x-axis. So now if we reflect this graph in the y-axis, it's going to be like this. Excuse my drawing, it's a little rough at the moment. But 1, 4 becomes your x value becomes negative now, and y value remains the same because we're reflecting it in the y-axis. So your y-axis acts as your mirror line. Whatever x value is negative becomes positive, or vice versa in this case. Now let's try another question. So it says the coordinates of the minimum point of this curve are 2, negative 3. Write on the coordinates of the turning point of the curve with equation y equals to f of x plus 2. So in this case, we're adding 2 directly to x, which means it's going to be a horizontal translation. And since we're adding something to x, that means we're going to move to the left-hand side. So what you will do is we will subtract 2 from the x value, which is 2. The y value remains the same. So that's going to give us 0, negative 3. So if we draw the graph, it's going to come over here. So this is going to be your turning point now. Then for y equals to negative f of x, as we said earlier, it's going to be a reflection in the x-axis because your y value is becoming negative now. So for that, it's going to be like this. So this is going to be 2, positive 3, because we reflected the graph in the x-axis. So this is a reflection in the x-axis. So that's 2, 3. Then for y equals to f of x plus 2, now we're directly adding 2 to the function, not to the x value. So that means it's going to be a vertical translation. And we're going to move 2 units up. So for 2 units up, it's going to be like this. So that would be 2 and -1. Because now we're adding 2 directly to the y value because it's a vertical translation. So it's 2, -3 plus 1, which is 2, -1. And then lastly, for y equals to f of -x, it's the opposite of what we did in b. Now we're reflecting in the y-axis. So now what's going to happen is that your x coordinate is going to be different. So if it's 2, -3 originally, it's going to be -2 and -3. So -2 and -3 is going to be over here. So these are your answers for these transformation of graphs. And now for question number 3, I want you to press pause first, answer all of these questions and share them in the comments below and see what you've understood so far. If you've understood how to do the vertical translation, horizontal translation, how to reflect in the x-axis and the y-axis. For A, it is y equals to f of x minus 3. And the turning point is -2 and 1. So if it's x minus 3, that means we're going to do a horizontal translation. And that means we're going to go towards the right-hand side in this case because we're subtracting 3. So that's going to be -2 plus 3. Y value remains the same, and that's going to give us 1, 1. So that's your first answer. Then part B, it's y equals to f of -x. So that is a reflection in the y-axis. So -2 will become +2 now. Y value remains the same once again. Then y equals to negative f of x plus 2. Now it's a double transformation happening over here. Your x value is changing and your y value is also changing. So if we change the x value first, we know there's a horizontal translation. So that's going to be -2. Why? Because we're adding 2. So we're going to move towards the left-hand side. So it's going to be -2, -2. Y remains the same for the first translation. So that's going to be -4, 1. Now, next translation is that it's negative f of x plus 2. That means we are doing a reflection in the x-axis. So what's going to happen now is your y coordinate is going to become the opposite. If it's positive, it's going to be negative now. So that's going to be -4 and -1. So that's your answer. Once again, in part C, there was a double transformation. For x value, there's a horizontal translation happening. We're going 2 units to the left. And for the y coordinate, it's a reflection in the x-axis. So if the y coordinate is positive, it becomes negative, which is the case over here. In part D, there's a double transformation happening again. It is f of -x minus 1. So for f of -x, there's a reflection in the y-axis. And for this -1, it's vertical translation. So for the reflection in the y-axis, your x-coordinate switches its sign. So if it's negative, it becomes positive. That's going to be 2, 1. And since it's moving 1 unit down, so we subtract 1 from the y value. So that's going to give us 2, 0. So that's your turning point for this complete transformation. Question number 2, it says the diagram shows a sketch of the graph of y equals to cos x. So as you can see, we have this graph for cos x, and it's asking us to write in the coordinates of the point A. So if you know the graph for the cosine function, the turning point is at 180 and cos equals to 1 at 0 and at 360. So that means this is 90 and this is 270. So for this, you need to know your actual values of the trig ratios, because cos 90 is equal to 0 and so is cos 20 and so is cos 270. And since this is over here, so that means A is going to be 90 and 0. That's a coordinate for A. Then part B says on the same diagram, draw a sketch of the graph of y equals to negative cos x. So as we discussed earlier, when your function is being made negative, like the entire function, what we do is we reflect the function in the x-axis. So that means it's going to be the opposite now. Your graph is going to look something like this. Like your maximum and minimum value is going to be the same, which is positive 1 and negative 1. And what happens is that your graph flips. So now your turning point is going to be at 180 and 1 instead of 180 and negative 1. Original function was y equals to cos x. The new one is y equals to negative cos x. As you can see, our x value is exactly the same. What has changed is our y value. Y value is now positive instead of being negative. In question 3, it says, here's the graph of y equals to sine x for the limit of x greater than equal to negative 180 and less than equal to 180. This is our graph. It says, on the grid, sketch the graph of y equals to sine x minus 2 for negative 180 to 180. So since it says y equals to sine x minus 2, that means we're going to do a vertical translation. And in this vertical translation, we're going to bring the graph 2 units down. Because from the value of sine x, we're subtracting 2. Since 2 is being directly subtracted from the function, that means it's going to change the y value, not the x value. So now over here, this was 1 and this was negative 1. So when you bring it 2 units down, this point is going to come over here. And this point is going to come over here. So it's going to be like this. As you can see, this point also came 2 units down. So did this and this. So our graph is moving 2 units down because we're subtracting 2 from the function. Question 4 says, here's a graph of y equals to sine x for negative 180 to 180. And on the grid above, sketch the graph of y equals to sine x plus 2. Now, in the previous part, we did sine x minus 2. So for sine x plus 2, we're going to move 2 units up. So this point over here will come over here. This will go from here to here. This becomes over here, and this goes over here and over here. So if you sketch it, it's going to look like this. Once again, there's a vertical translation. Now we're going 2 units up. So as you can see, our x value is exactly the same. What's changing is the y value. Over here, your point is becoming negative 90 and 1. This is going to be negative 180 and 2. This is 0, 2. This is 90 and 3. And this one is 180 and 2. Part B says here's the graph of y equals to cos x for negative 180 to 180. On the grid above, sketch the graph of y equals to negative cos x for the same range. So like we did previously for negative, we're going to reflect it in the x-axis. The reason why we're going to reflect it in the x-axis because we're changing the entire cos function and multiplying it by negative sign. We're not multiplying the negative sign directly by x. The entire function is becoming negative. So it's going to be a reflection in the x-axis. So what's going to happen is that your y coordinates are going to change. So if the y coordinate is positive, it becomes negative. So this will come over here. This was negative, so this will become positive. Same with this one. So now as you can see, it's going to be upside down. Like this. So this is your graph for y equals to negative cos x. And as it's visible, it's a reflection in the x-axis. Question 5 says the equation of a curve is y equals to a to the power of x. A is the point on the curve where the curve intersects the y-axis. State the coordinates of A. So if A is the point where the curve intersects the y-axis, that means x is going to be 0. So if x is 0, y is going to be a to the power of 0. And anything to the power of 0 is equal to 1. So your coordinates of A are going to be 0 and 1. The reason why I put x equals to 0 is because any point that lies on the y-axis, the x value is going to be 0. Because that point is going to be your y-intercept. And for the y-intercept, x is always 0. Whereas for the x-intercept, y is always 0. 5b says the equation of a circle C is x squared plus y squared equals to 16. The circle is translated by the vector 3, 0 to give circle B. Draw a sketch of circle B and label with coordinates the center of circle B and any points of intersection with the x-axis. So if the circle B is translated by the vector 3, 0, that means we're subtracting 3 from the x value of the origin. It's going to be x minus 3 whole square plus y square equals to 16. So now if we draw a rough sketch over here, if originally your circle was this, okay? This is r square. So that means your radius is going to be 4. So since the origin is the center, so this is 4, this is negative 4, this is 4, and this is negative 4 as well. So for the transformation, we are subtracting 3 from the x coordinate. So 0, 0 would become negative 3, 0. So that's over here. This is your center now. So since the radius is not changing, radius is being the same, 4 would move to 1. And negative 4 would move to negative 7. So your y coordinate is going to be the same because the translation vector is just 3, 0, not 3, 3. So only thing that's changing is the x coordinate. So if we draw the graph for this, it's going to be like this, approximately. This is your y equals to 4 over here, y equals to negative 4 over here. And this is your point where x equals to negative 7 and x equals to 1 is over here. So center of circle is negative 3, 0. And points of intersection of the x-axis are this negative 7, 0. And this is 1, 0. This is going to be your sketch of circle B. The next question says, here's a graph of y equals to cos x for x is greater than equal to 0 and less than equal to 360. In parts A and B, the graph of y equals to cos x is shown as a dashed line. On the grid, draw the graph of y equals to cos of x minus 90 for the same range. So for x minus 90, we're subtracting 90 from x. That means we're going to do a horizontal translation. And we're going to move 90 degrees to the right. The logic is same as we did for the other functions, like the non-trigonometric function. Something is being directly added to x, you move that many units to the left-hand side. If something is being directly subtracted from x, you move that many units to the right-hand side. Since 90 is being subtracted from x, so that means you will move 90 degrees to the right. So this 90 degrees becomes 180. This 0 becomes 90. And your 180 becomes 270. So this will be over here. And 270 is 360. So if you notice, your graph is going to be shaped like this. This is y equals to cos of x minus 90. As you can see, there's a horizontal translation of 90 degrees to the right-hand side. Then part B says, on the grid below, draw the graph of y equals to 1 plus cos x. So for 1 plus cos x, it's going to be a vertical translation. And going to move 1 unit up. So this 1 becomes a 2. This 0 becomes a 1. Negative 1 becomes 0. 0 becomes 1 and 1 comes over here at 2. So this is your graph for y equals to 1 plus cos x. As we said earlier, nothing is going to happen to the x value. That's going to be exactly the same. What's going to change is your y value. In part C, it says Rita tries to draw the graph of y equals to cos of negative x. Here is a graph. Give reason why Rita's graph is incorrect. So Rita's graph is incorrect because she has shown a reflection in the x-axis, which is completely wrong. Because when your x value is negative, that means you're reflecting in the y-axis, not the x-axis. X-axis reflection happens when it's y equals to negative cos x. This is the graph for that. So to draw the graph of y equals to cos of negative x, what we're going to do is we're going to make it like this. First, let's draw the original graph. This is the original graph. This is y equals to cos x. Y equals to cos of negative x is going to be like this. All right. Let me draw the axis first over here. So we will have 90 over here, 180, 270, and 360. So this is just a rough graph. So it's going to be basically like this. This is going to be y equals to cos of negative x. Your y-axis acts as a mirror line. So we reflect the entire graph in the y-axis. And as you can see, our x values become negative. The y value is actually the same. It's positive 1 and negative 1. But your angles change. 90 becomes negative 90. 180 is negative 180. 270 is negative 270. And 360 is negative 360. So what was wrong with Rita's graph? She showed a reflection in the x-axis instead of showing it in the y-axis. Question 9 says, here's a sketch of y equals to f of x. The curve passes through the points negative 2, negative 10, negative 1, negative 3, 0, negative 2, 1, negative 1, and 2, 6. On the grid, sketch the curve of y equals to f of x plus 2. So f of x plus 2 means that we're going to do a horizontal translation. And we're going to move 2 units to the left. As I said earlier, for the horizontal translation, the rule is different. If it's being subtracted, that means you move that many units to the right-hand side. And if it's being added, you move that many units to the left-hand side. So if you move 2 units to the left-hand side, this point will become this point, and this will become this. This becomes this. This becomes this. So, and this will be this. So if we draw the sketch, it's going to be something like this. Like, I know it's a little rough, but like, to get an idea, basically you're moving all of the x values 2 units to the left-hand side. That's your graph. Question 10 says the curve with the equation y equals to x squared minus 5x plus 2 is reflected in the x-axis. Circle the equation of the reflected curve. So for the reflected curve, if it's reflected in the x-axis, that means we are changing the y values. Their entire function, if it's y equals to f of x, it's going to become y equals to negative f of x. So since y is x squared minus 5x plus 2, y equals to negative x squared minus 5x plus 2 will basically be negative x squared plus 5x minus 2. And that is this one. So this is the equation of the reflected curve. Question 11 says the graph of y equals to cos of x minus 30 for 0 to 360 crosses the x-axis in 2 places. Write down the values of x where this occurs. So to understand this better, I'm just going to draw a rough sketch of y equals to cos x from 0 to 360. 0, 90, 180, 270, and 360. This is negative 1, this is positive 1. So since it's y equals to cos of x minus 30, that means it's a horizontal translation. And we're going 30 degrees to the right side. So when we go 30 degrees to the right side, 90 will become 120. So that's going to be over here. And 270 becomes 300. So they want the value where the graph crosses the x-axis in 2 places. So that was initially for the cos graph, it was 90 and 270. So 90 and 270 become 120 and 300. So 120 and 300. These are x values. For question 12, it says sketch the graph of y equals to negative sine x for 0 to 360. So first, I want to sketch the graph of y equals to sine x so that you understand how we transform it. This is y equals to sine x. So for y equals to negative sine x, we're going to reflect it in the x-axis. So it's going to be like this. Whatever was positive for y becomes negative and x remains the same. So positive 1 becomes negative and negative 1 becomes positive. And that is your answer.